Okay, hello. This video is going to be on 4.5 day 2, and when you're done with the video, um, if it's necessary, there might be 2 parts to the video, but maybe not. But when you're done watching the videos, there is on the chapter 4 page, to the right of where you found the link to this video, there's a 4.5 worksheet that you need to download and print and do, or if you want to do it on a separate sheet of paper, that's fine too. Okay, so the homework tonight is the 4.5 worksheet. All right, so yesterday we looked at the amplitude, which is how high up and down the bumps go, amplitude, and then the period is a horizontal stretching and shrinking, like a slinky stretching and shrinking or an accordion. Now today what we're going to look at is shifting left and right and up and down, and what makes the graph do those things. Up in this green box, this is a general form of sine and cosine, and what we talked about yesterday was A, the amplitude. So again, that's how far up and down the bumps go. And then we talked about B, how B is in front of the X, and that changes the period. The period is 2 pi divided by whatever that B value is. And now what we're going to talk about today is what these H and K values do. So this is similar to all the other types of functions we've done with shifting left, right, up, and down. If the value is inside the parentheses, that's your shift left or right. Okay, if you are adding that H value, it's going to shift to the left, and if you're subtracting that H value, it's going to shift to the right. The K value out at the end, that is your up and down. If you are adding the K value, it's going up, and if you're subtracting the K value, that'll make it go down. Now, sometimes this K value at the very end might be written out in front. So it could look like this: K plus A sine B times X minus H. That K value could be out in the very, very front. If that bothers you, you can always just rearrange it and put it at the end. Now, these K and A and B and H values, those are potentially different letters than what's in the book. I'm pretty sure they're different than what's in your book. So just be aware of that. Okay, so we're just going to do examples now, okay? So here is our function, sine x. That's the parent function. And now we're going to do a -1 shift. Well, which way does that go? Well, do you see how it's outside of the function? That's a shift down 1. So what we're going to do is we're going to graph the sine function first. Then we're going to shift it down 1. Okay, well, what's the amplitude? Well, the amplitude's a 1. And the B value out in front here is just a 1. So the period is 2 pi. Because you know how it's 2 pi divided by B? Well, 2 pi divided by 1 is 2 pi. So make your 4 tick marks. The last tick mark is the period. Halfway, half of 2 pi is pi. Half of pi is pi over 2. Multiply that by 3 to get the third tick mark, 3 pi over 2. Okay, now sine has a beginning, a middle, and an end at 0. And it goes up first and down second. Now I'm going to make this dashed because this is not our final answer. This is just the sine graph. Now what we need to do is shift that whole thing down 1. So I'm going to have to add another tick mark. So every point's going to go down 1. That's down 1, this is down 1, this shifts down 1, this shifts down 1, and that one shifts down 1. Okay, and then connect the dots with a curve. Okay, now can you imagine a little like horizontal line at -1? Do you see how these 3 dots are on that imaginary horizontal line? That's something I'm going to check for when I'm looking at your graphs. On a sine graph, these 3 dots should be on a horizontal line. And wherever that horizontal line is, that's kind of indicating where it shifted, up or down. Okay, next one we're going to do is this one. Well, this one has a shift, but do you see how the minus pi is within the parentheses? That's a shift left or right. Since it's a minus pi, that's a shift to the right by pi. Okay, well, start with just the sine x graph. So we've already done that. Let's just redo it. Sine has a period of 2 pi. So make your 4 tick marks. The last tick mark is 2 pi, and so on. Sine, again, has a beginning, a middle, and an end at 0. It would go up first, down second. So here is sine. Okay, well now what we need to do is shift it to the right pi. Well, how much is pi? It's 2 tick marks, right? Pi is the second tick mark. So we need to shift everything to the right 2 tick marks. So that means we're going to probably need to add on 2 more tick marks. Okay, so we got to label those. We've got 1/2 pi, 1 pi, 3/2 pi, 2 pi. Okay, now if you think about it, it's going by 1/2. So this is 1/2. This would be 2 halves, 3 halves, 4 halves. So this is 5 halves. And then wouldn't this be 6 halves? Well, 6/2 reduces down to 3, so 3 pi. 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Okay, so now shift everything to the right pi. That's 2 tick marks. So this is going to go 2 tick marks over. This is going to go 2 tick marks over. This point is going 2 tick marks over. That one is going over 2 tick marks. And this one's going over 2 tick marks. So now it looks like this. Okay. Okay, now we're going to do cosine with a shift. So it's a shift which way? If it's inside the parentheses, that's left or right. It's a plus pi/2, so that would be a shift to the left. So let's start with just the basic cosine graph. Okay, so just the parent function cosine. All right, cosine has an amplitude of 1 and a period of 2 pi. So make your 4 tick marks. The last tick mark is the period. Half of 2 pi is pi. Half of that is pi/2. Multiply that by 3. That's 3 pi/2. Now remember, cosine has a beginning and an end up high. Halfway in the middle is where it dips down low, and then it has to cross through 0. So here is cosine, and now we need to do our shift. We're going to shift to the left pi/2. That's only one tick mark worth. So I'm going to put a tick mark over here on the left. If this is positive pi over 2, then this would be a negative pi over 2. And I'm going to shift everything to the left, one tick mark. And that's my graph. Feel free to pause anytime you need to keep writing down. Okay, now this problem has everything in it. One thing that you might want to take note of is this number, this 1, is outside of the function, and some people like it better written at the end. So if you want to write this down as y equals 2 sine pi over 4 x plus 1, and now this is a positive 1, so plus 1 on the outside, at the end, if you like that better, go ahead and do that. Okay, so let's go through. Here's my suggestion. Do the amplitude and period first, then do your shifting. Because there's kind of a lot going on in this problem. So I would do the period and the amplitude first. So here's the amplitude. The amplitude's 2. So it's going to go up to 2 and down to negative 2. B is pi over 4. So to find the period, you have to do 2 pi divided by b. So in this case, it's 2 pi divided by pi over 4. Well, instead of dividing by pi over 4, we could multiply by the reciprocal, which would be 4 over pi. And those pi's cancel, so 8 is the period. So make your 4 tick marks. The last tick mark is 8. Half of 8 is 4, half of that is 2. Multiply that by 3 and you get 6. Okay, now we're graphing sine with this period and amplitude. Sine has a beginning, a middle, and an end at 0. It goes up first, down second. Now this is not my final answer, so I'm going to make it dashed. This is only the period and the amplitude. Now we're going to do our shifting. So if we are adding 1 inside the function, that would be a shift to the left, 1. And if we're adding 1 outside the function, that's a shift up 1. All right, now be careful with your tick marks. We're going to have to shift everything up 1, so we're going to have to add a tick mark up there. Now careful, we have to shift to the left 1. But do you see how 1 tick mark is going by 2's? I'm supposed to shift to the left 1, so I'm going to have to put in these like intermediate tick marks. And probably a negative 1 here. So now I'm going to shift all of those green dots to the left 1 and up 1. So if I go to the left 1 and up 1, that would put me right here. This to the left 1 and up 1. Here to the left 1 and up 1. Here to the left 1 and up 1. And then to the left 1 and up 1. Okay, connect those dots. Okay, now do you remember what I was saying about the like imaginary horizontal line? These 3 dots should be on the same horizontal line at 1 because it was a shift up 1, right? So when you're drawing your graph, make sure that you can see those 3 dots on that kind of imaginary horizontal line.